Hi all. See that in this particular problem, it actually asks that multiple option on this particular problem may possible, right? That's the problem it's asked, right? So see that here it's appeared in 2009 main paper, right? So see that here the curves are very simple. Y equal to e to the power x, right? So you all know that y equal to e to the power x between 0 to 1 means that it's an increasing function, right? We know that y to the power x is an increasing function, and let's see that. So therefore, if I able to plot that, this will be our y equal to e to the power x graph, right? It lies between x equal to 0 and x equal to e, right? So this is the line is there, right? Let's see that. Whatever we are having it here, right? So it says that it lies between x equal to 0 and x equal to e. So therefore, this is our shaded region is the required region. So it is our curve y is equal to e to the power x. So this is y is equal to e to the power x. It lies between x equal to 0. So that means that x-axis. It lies between the curve y is equal to e. So y equal to e means that this is the line y equal to e. I just wrote it here, okay? So that's it, right? So this is the required region. So you already calculate that we can find the shaded region and all that stuff, right? Now see that what will be the 0? Like here y equal to e means the horizontal line, not the vertical one, right? Because the vertical one I just drawn it to find the limits. That's it, okay? Now see that we have to find that the point of intersection. Now as it is curve is drawn properly, so you can understand that it is lies between, okay, that some values here and also some upper values in that limit, right? So that is y equal to e. What is that line? That is y equal to 1. Why? Because if I this line is y equal to 1, right? So what is the shaded region? The shaded region we can easily find it is bounded by the top curves, okay, the right curve and the left curve is 0. So that's it. So here we have to write down that in the form of x equal to function of y. So let's start with our problem. So we'll see that y is equal to e to the power x. So it's imply that, right, that x is equal to log y. So now the shaded region is bounded by x is equal to some function of y, so x equal to log y, x is equal to 0 in the interval y belongs to 1 to e. So therefore, you can say that the required area A, if I consider, that's equal to 1 to e ln y dy. That's it. So we can easily calculate the final value. So therefore, for this particular problem, obviously you can see that option D is the right answer. But obviously, in this case, right, there may be the multiple options are possible, right? So we have to test for the other options as well, right? Now see that for the second, for the option C, right? Option C, it's talk about that we need to find out the area, right? We need to find out the area in the x, if I talk about the x limit, right? Now see that if I talk about this rectangle, right? If I talk about this rectangle that is A, B, O, and see that this is actually C, okay? I just make some rectangle OABC. Now, what is the area of this rectangle OABC? So, see that the area of OABC, area of the rectangle O, A, B and C, that gives me that what is that length, what is the breadth, that is E, right? Because it is actually E. So this height is E and this distance OC is actually 1 unit. So therefore you can see that in this, from this figure, OC is actually 1 unit and BC is actually E. So using that property, right, that proper multiplication of that breadth and height, we can see that it is OC multiplied by BC, and that's equal to E. So that's the area of the total rectangle, right? Now, what is the shaded area? Shaded area is bounded by that. If I take that another region, right? Let's take that point as D, and that's it, right? So see that the shaded area, shaded region, we consider that area of the rectangle OABC minus the area, okay, that ODBC, right? ODBC. Now, this area ODBC means that we are talking about this particular region, okay? Now, see that if I trying to calculate that, what is this region? This is the region bounded by the curve y equal to e to the power x between, right, x is equal to 0 to x is equal to 1, right? So, therefore, we'll say that where ODBC is the area or the region bounded by y is equal to e to the power x, y is equal to 0, x-axis inside the interval x belongs to the interval 0 to 1, okay? So, therefore, the required area A here, that's equal to E minus integration of 0 to 1 e to the power x dx. So, that's why for this particular problem as well, that option C is also the correct option. So, now both option is correct. Now, we cannot leave these two options, okay. So, let's test that other two option as well. So, first we remove that shaded region, okay. Okay. Now, let's go ahead and take that integration, okay. First, we talk about that integration. So, here we are talking about the integration of 1 to e log of e plus 1 minus y dy. Now, see that here we can easily see that whatever the region, right? Now, see that that's it. This is the area we are talking about. Why? Because see that if we apply the limit, right? We already know a property of that integration, right? Let's recall that property. Okay. So we already know that some integration of a to b fx dx can easily be written as integration of a to b f of a plus b minus x and dx. So, if I apply this particular properties on the expression 1, right? So, we can say that by 1, that area can be easily written as integration of 1 to e log of e plus 1 minus y dy. So, see that this is also the given information. So, therefore, option B is also the correct option. So, now we don't know anything about that e minus 1, right? I don't know, right? Because this is there is no integration or nothing is available, right? Now, see that, right? If I trying to calculate that particular values, right? We may get that answer, right? Now, let's see that what will be the possibilities, right? So, see that here, what is my area? So, we just consider that and trying to do the integration. So, it's say that it's e minus integration of 0 to 1 e to the power x dx. So, we know this formula. So, therefore, we can say it's e minus e to the power x 0 to 1 0 to 1, that's it. So, that's imply that it's e minus e to the power 0. That's imply that it gives e minus 1. that means it's equal to 1. So therefore, we can easily say that for this particular problem, option A is not the correct option. So therefore, for all cases, right, whatever the area is actually having 1 unit, not E minus 1 unit, right? So that's it. So therefore, option B, C, D is all three are correct, not the option A, right? And that's it. Hope you understood the problem. Thank you.